Good morning, students. Now we can see region of convergence. What is meant by region of convergence? It is defined as the function x of s converges for all the values of s. That is, x of s, the Laplace transform of any signal. So, if you take, for example, s plus 1, okay, if you take all the values of s, any value, s is equal to 0, 1, 2, 3, all the values, that is real part of value, this x of s must be finite value. Converges means finite value. So this is nothing but region of convergence. The region of convergence is used to obtain stability of a system. If you design any system, to calculate the stability, we need to find the region of convergence. So, the Laplace transform for any signal must be converges for all the values of s. It has 7 properties. Property number 1, the region of convergence x of s consists of parallel strips to the imaginary axis. So you all know that this is y-axis, this is x-axis, this is sigma, this is j omega, okay, this is called s-plane. This is called s-plane. So in the s-plane, okay, the consist of parallel strips to the imaginary axis. Imaginary axis is j omega. So the region of convergence is the parallel strips. Okay, this is called region of convergence. Is it clear? So the region of convergence, if you draw a parallel lines, all the points must be converged into that portion. That is the first property. The ROC of x of s consists of parallel strips to the imaginary axis. The next property 2 is the ROC of Laplace transform does not include any pole of x of s. For example, you take a y-axis, x-axis, sigma, j omega does not include any pole means, for example, if you have a parallel strip, okay, for example, x of s is equal to 1 divided by s plus 3 or minus 3. So what you will get the pole? S is equal to minus 3. So this minus 3 must be lies here. This is minus 3. For example, you have it. Okay, this is called parallel strips, region of convergence. Okay, if the pole, whatever the pole, for example, this is plus 1, this is minus 1, okay, the pole lies in this parallel strip, it is not a correct answer. Okay, as per the property, the Laplace transform does not include the region of convergence. So this is the ROC. The ROC does not contain any poles. So the x of s, the pole is s plus 3. Okay, what is s is equal to minus 3. So this is placed outside the parallel strip. Okay, so actually this is correct. If the, for example, if this is s plus 1 minus 0.5 means it is located inside the parallel strip means it will give the wrong result. Okay, so the region of convergence does not consider any pole. That is the meaning of the property. Okay, Okay, whatever the pole, that must be lies outside the region of convergence. This is correct. Okay, for example, if x of s is equal to 1 divided by s plus 0.5. So what answer you will get? S is equal to, this is the pole, S is equal to minus 0.5. So what it will happen? This is you will get internally. This is minus 0.5. So what will happen? As per the property, the region of convergence does not contain any poles. So it does not have any poles. But as per this problem, it has pole located inside the region of convergence. This is wrong. Okay. If you look at this part, here s is equal to minus 3. It lies outside. So this pole will be considered. So this is the property explains. The next property is if x of t is a finite duration signal and is absolutely integrable, then the ROC of x of s is entire S-plane. If x of t is finite duration, that is you take x of t is finite duration. I think you all know it very well. That is within a bracket you take 1, 2, 3. So this is called finite duration. Okay. If I put arrow here, what it represents? This is positive axis amplitude. This is negative axis amplitude. If the x of t is finite duration signal and it is absolutely integrable, the ROC is entire S-plane. This is sigma. This is j omega. Okay. Now the ROC is entire S-plane. Okay. So the whole S-plane, this is called the S-plane. The whole S-plane is the region of convergence. Is it clear? That is the statement of property 3. Then the property 4 is, if x of t is right-sided or causal signal. All of you know that what is meant by causal signal. X of t is equal to, okay, is not equal to 0 for t is less than 0. If x of t is right-sided sequence, for example, the sequence is like this. This is right-sided sequence. Okay, this is x of t. This is t. This is u of t. All of you know very well. Okay, this is called a right-sided signal or causal signal. That is the ROC of x of s. So this transform as extends to the right of the rightmost poles and no pole is located inside the ROC. So this is sigma j omega. So the pole located only it is in the right sided. If it is sigma equal to minus a, that is the pole is minus a. If pole is plus a, you will get like this. This is sigma. This is j omega. Okay, if you take, you will get this part. Okay, this is a, you take it plus a. So this is the portion of the ROC, region of convergence. So the pole must be either plus or minus, but always it presented the right side. This is called region of convergence. Similarly, if you take left-sided signal, so all of you know that the left-sided signal is So the left-sided signal is you take. So this is left-sided signal. This is u of minus t. Okay, u of minus t, this is t. This is left-sided or non-causal signal. Okay, if you have the signal is like this, the ROC is only it present at the left side depending upon the sigma value. Sigma is minus b or plus b. It must be, this is for minus b, I have given like this. If it is plus b, you will get the plot like this. Okay, this is sigma, this is j omega. Now if you take the sigma is b plus b, what will happen? So the region of convergence is this portion, left-sided. Do you know the difference between the first one and the second one? Okay, if the property 4 says that right-sided means the ROC lies only in the right side. If the signal is left-sided, the region of convergence is placed in this one. So here sigma equal to minus b. Here the sigma is the plus b. For both you will get the same result. The next property is, if x of t is two-sided signal, the region of convergence is the parallel strip, two poles. Okay, so bounded by poles and no poles lies between the ROC. Okay, so you should not contain, this is the parallel strip or bounded region. It does not contain any poles. Okay, that is the property. Does not contain any poles. Does not contain any poles. Is it clear? Okay, this is the region. This region does not contain any poles. Okay, so if you have a two-sided left side, for example, the x of t is, this is x of t, two-sided left side and right side, this is t. Okay, if you will get, already we studied fourth one, if it is a right-sided means the ROC is right-sided. If it is left-sided, the ROC is left-sided. If the signal is two-sided, you will get in the form of boundary. Okay, parallel strip. Okay, so this is called, the boundary does not contain any poles. This is the property 6. The property 7 is, impulse function is the only function for which the ROC is entire S-plane. Impulse function is, everyone you know that x of t is equal to del of t. This is impulse function. Okay. What is the Laplace transform of it? X of s is equal to 1. Laplace transform of the impulse function is 1. So if I do, you take a sigma, this is j omega. Okay. If it is 1 means the ROC is entire S-plane. So this is S-plane. So the ROC is entire S-plane. So the region of convergence is entire S-plane. Clear? So this is the properties of region of convergence. This is used to obtain the stability of an system.